Okay, so I feel like we've talked enough about inequalities and solving inequalities and what happens when you divide or multiply by a negative that I just want to run through a few examples of you here with a few two-step inequalities because that's kind of the next piece of the puzzle. Not only are we going to solve these two-step inequalities, we're going to graph them. So let's try it out. Here I have 4w minus 2 is less than or equal to negative 10. So solve this just like you would solve an equation, right? Maybe start with, if you want to do a do-undo table, or whatever works for you, right? So if I'm thinking about what's being done to w, the first thing is that I do 4 times w and then I subtract 2. So then to undo that, I would add 2 and divide by 4. So let's do that here. 4w minus 2 is less than or equal to negative 10. I add 2 to both sides. 4w is less than or equal to negative 8. Divide both sides by 4. And w is less than or equal to negative 2. Okay, now notice I didn't flip the sign here. Remember, you only flip the sign when you divide or you multiply by a negative. That's the only time that you flip the inequality sign. Even though I divided a negative by a positive, that's okay. Only when you divide or multiply by a negative. So here we have w is less than or equal to negative 2. So negative 2 is right here. It's less than or equal to, so I fill in that circle. And then I shade over here to this side, maybe even increase my brush size a little bit to make it easier to see. Oh yeah, that's really doing something. So everything on the left-hand side, right? Everything on the more negative side of negative 2, that's what I'm, those are the numbers that are in my solution, right? Those are the numbers that w could be. Okay, let's look at least one more. That was not too bad. Okay, 33 is less than 44 plus 11n. So this is interesting because my variable is on the right-hand side, but that's okay. We'll take care of that at the end. So if you want to think about the do-undo table, it's a little more than I want, the do-undo table. So within, I would first multiply by 11, and then I would subtract 44. So that means add 44. So I need to subtract 44 from both sides. That's interesting. And then I need to divide by 11. Okay, so let's do that. 33 is less than 44 plus 11n. So subtract 44 from both sides. Negative 11 is less than 11n. Divide by 11. And again, be careful. I'm not flipping the sign here. I'm dividing by a positive number, so I don't need to flip the sign. So then that's negative 1 is less than n. Well, negative 1 is less than n. That means that n is any number. That means that n is any number greater than negative 1, right? Negative 1 is less than n means that no matter what number n is, negative 1 is always less than it, right? So that's the same as saying n is greater than negative 1. Now this is just greater than, so if I'm shading this, I have an open circle there. And then shade this way, right, to the right. And that's my solution set for this equation. And you can check that, right? If you wanted to put a number in here, even 0 is an easy number to check. 44 plus 0 is 44, and 44 is definitely greater than 33. So that feels pretty good when we're thinking about, does my solution make sense? Okay, just one more. If I can find it. There we go. Okay, t divided by -2 minus 1 is greater than 1. So again, thinking about the do-undo chart here, this is just the way that I like to think about my equations. Okay, so the first thing I would do to t is divide by -2. And after dividing by -2, I would add 1 to both sides. Sorry. I would subtract 1 from whatever number that is, right? Divide t by -2, and then whatever that number is, subtract 1. So in order to undo that, I need to add 1 to both sides, and then I need to multiply both sides by -2. Struggling. Okay, so let's try that. T minus 1, oops. T divided by -2 minus 1 is greater than 1. Okay, so I add 1 first to both sides. Because remember, I go this way and then that way because I'm undoing. Add 1, t divided by -2 is greater than 2. Multiply both sides by -2. And now, remember, and we've talked about this in the past, but remember, if you multiply or divide both sides by a negative, so here I'm multiplying both sides by -2, then I need to flip my inequality sign. So t is less than -4. Because I'm really flipping the whole script here. So t is less than -4. Well, -4 is here. And t is less than that. So right here, we go that way. T is less than -4. And if you want to check a solution, check it with your original equation, right? So even now, right, if I had done this the other way, if I had said t was greater than -4, then any of these numbers would work. So let's try 0, because I really like 0 as a solution. It's an easy one to check, usually. So here we go. 0, if I did this is me, I'm checking my work. 0 divided by -2 minus 1 is 0 minus 1, or -1. And -1 is not greater than 1, right? -1 is over here, right? And that's not greater than 1. So, well, yes, yeah, because any number greater than 1 would be over here. So for our solution, that makes sense, right? It's not part of my shaded region. It's not part of my shaded region, so you can feel good about your solution and feel good about flipping that inequality sign. Like I said, there wasn't too much to talk about here, just solving some problems, hopefully getting you a few tricks up your sleeve so that you can solve inequalities that require more than one step.